The case for 3I/Atlas being something more than an ordinary comet begins with its chemical fingerprint, a clue that has baffled astronomers since the first spectroscopic readings were captured. In the vast creative furnace of the universe, where stars collapse, explode, and scatter the building blocks of planets and asteroids, certain elemental pairings are so consistent, so foundational, that they form the baseline for identifying natural cosmic objects. Among these pairings, nickel and iron stand out as inseparable partners. From meteorites recovered on Earth to ancient asteroids orbiting in the belt between Mars and Jupiter, these two metals appear together with predictable reliability, forged in the same stellar processes and distributed throughout the galaxy in tandem. They are, as astrophysicists often put it, cosmic twins, born from the same nuclear events, and destined to appear side by side in nearly every natural object we have ever analyzed. But 3I/Atlas has defied this cosmic rule in the most dramatic way imaginable. When astronomers trained their spectrographs on the object, expecting the usual cocktail of metals, volatiles, and ices typical of comets, they found something so unexpected that several researchers assumed there had been an error in the early readings. The data showed a plume of pure nickel gas streaming off the object, forming a long, shimmering tail that reflected sunlight in a distinct, metallic way. Pure nickel. Not nickel mixed with iron, not nickel alloyed with carbon or sulfur, but nickel entirely on its own, with iron nowhere to be found. This chemical anomaly is so severe and so unprecedented that it immediately set 3I/Atlas apart from every other naturally occurring comet, asteroid, or interstellar fragment ever observed. To put this into perspective, even the rarest types of nickel-rich meteorites found on Earth still contain iron. In fact, the ratio of nickel to iron in normal cosmic material is so stable that it is used as a diagnostic tool for identifying extraterrestrial objects. Iron does not simply vanish from natural cosmic environments. It is one of the most abundant elements produced in supernovae, and it is chemically bonded with nickel in almost all known astrophysical environments. For 3I/Atlas to be venting pure nickel gas means something profoundly unusual is happening, something that current astrophysical models struggle to explain. The anomaly becomes even more striking when considering how comets actually work. Comets are often described as dirty snowballs, icy bodies that spend most of their time in deep freeze, wandering the outer reaches of their star systems. When they approach a star's warmth, their surface ices vaporize, releasing gases and dust that form a tail or coma. These gases are predictable: water vapor, carbon dioxide, carbon monoxide, small amounts of methane or ammonia, and trace metals liberated from the comet's rocky interior. The release of pure metallic vapor, especially one as heavy and energetically demanding to vaporize as nickel, is unheard of in natural comet science. For nickel to turn into gas, the material must be heated to temperatures far beyond what is normally present on the surface of a comet. Moreover, even if such heating somehow occurred through friction, tidal forces, or an internal heat source, it would still liberate iron alongside the nickel, because the two metals are bound together at the atomic level in natural cosmic materials. This stubborn absence of iron cannot be explained through conventional astrophysical processes. It cannot be chalked up to observational error, because multiple telescopes confirmed the readings. It cannot be attributed to selective heating, because the physics of metal vaporization do not permit nickel to escape while iron remains bound. Nor can it be dismissed as a rare type of exotic comet, because no known formation mechanism in stellar astrophysics produces a body composed of pure nickel without iron. The universe simply does not make such materials on its own, not through star formation, not through planetary differentiation, not through supernova remnants, and certainly not through the creation of icy, comet-like bodies. This is why Dr. Avi Loeb and others have pointed to the possibility of non-natural origins. The idea is not grounded in fantasy or wild speculation, but in the cold, rigid data. Pure nickel gas is not something nature produces in isolation, but it is something produced in advanced industrial processes. On Earth, nickel is refined into pure form through smelting, electrochemical separation, and metallurgical engineering. High-purity nickel is used in aerospace components, high-performance alloys, heat-resistant structures, and magnetic technologies. In fact, the only known environment where nickel exists in pure, isolated vapor form is in industrial manufacturing. Factories that refine or vapor deposit nickel create gas clouds that, in their spectral readings, look eerily similar to what 3I/Atlas is producing. That does not mean the object is a machine, a spacecraft, or a piece of alien hardware, but it opens the door to such interpretations in a way no previous interstellar visitor ever has. Because if a material does not occur in nature, and yet it is being actively vented in space, logic demands that we consider the possibility that it was engineered. This is the reasoning behind Loeb's assertion that we cannot simply dismiss the idea that 3I/Atlas might be artificial. The statistical argument he presents hinges on the fact that every natural explanation offered so far contradicts known physics, known chemistry, or both. Meanwhile, the artificial explanation, while extraordinary, does not contradict any known laws. In science, the explanation that breaks fewer rules tends to carry more weight. The implications of pure nickel outgassing go beyond chemical composition. If the material is artificial, it raises questions about the internal structure and purpose of the object. Why would a piece of advanced technology be shedding nickel gas? Is it a byproduct of propulsion? Is it a sign of degradation, like metal panels eroding over time? Is it part of a system we do not yet understand, such as a heat shield, a reflective surface, or a power generation mechanism? Could it be an ancient artifact drifting through the galaxy, its original function long expired? Or could it be something more active, a probe or device deliberately engineered to mimic a comet until it approached a star system worth observing? Each of these possibilities sounds like science fiction, yet none can be fully ruled out based on the data we currently have. The simplest explanation remains elusive, and in the absence of a natural mechanism, the artificial hypothesis gains a foothold by default. Scientists generally prefer to avoid such thinking unless the evidence demands it, but in this case, the evidence is refusing to behave normally. There is also the question of where 3I/Atlas came from. Interstellar objects like 1I/Oumuamua and 2I/Borisov have shown us that the galaxy is full of debris moving between star systems. But even these objects adhered to expected chemical norms. Oumuamua was puzzling in its shape and acceleration, yet its composition seemed natural. Borisov was essentially a textbook comet. 3I/Atlas breaks the pattern entirely. If it was formed in some distant planetary system, that system must have had physical processes different from anything we know. If it did not form naturally, then it may be evidence that technological civilizations exist elsewhere in the galaxy, manufacturing materials that eventually drift through space. What makes the nickel anomaly even more fascinating is the scale of the plume. The amount of gas being released suggests that the nickel reservoir inside the object is substantial, large enough to maintain vaporization over a sustained period. Natural comets do not contain such reservoirs. Even metallic asteroids, which do contain higher amounts of nickel, do not spontaneously vaporize metals without proximity to extreme heat. And 3I/Atlas is not near any such heat source. Its surface temperature is far too low to account for the vaporization. Some researchers have proposed exotic explanations. Perhaps 3I/Atlas contains radioactive materials generating internal heat. Perhaps it underwent a recent collision that stripped away the iron. Perhaps it formed in an unusually cold stellar nursery, where iron bonded differently. Yet every proposal so far has encountered insurmountable scientific contradictions, forcing the mystery to persist. In science, anomalies are precious. They reveal the limits of our understanding and challenge us to reconsider assumptions once thought unshakable. The nickel gas streaming from 3I/Atlas is not merely an anomaly. It is a direct affront to the known rules of cosmic chemistry. It forces astronomers to step into uncomfortable territory, where the line between natural and artificial becomes blurred. Whether or not 3I/Atlas is truly alien technology remains uncertain, but its chemical fingerprint alone justifies the profound attention it is receiving. The universe rarely hands us such a perfect mystery, and even rarer still do we encounter one that hints, however faintly, at the possibility that we are not alone.